There's a good chance you've already seen this before in high school, but I'm going to really quickly review the different circuit elements that we're going to see. The first element is very basic, just a wire. And the idea here is that we're using a conductive material that has free electrons, and the free electrons can flow from one side to the other because it's a conductor. Just like what we saw in Chapter 1, except now with the circuit, we're actually setting up an electric field that causes electrons to keep flowing continuously, and that's called a current. The next thing is something called an EMF. And an EMF is often also called a voltage source. And the symbol for an EMF has one long line and then a space and a short line. And then there are wires connecting the top and bottom. And often on the long line there's a plus to indicate that the long line is positive. There might not always be a positive like that, but the long line, if there is no plus sign, then the long line indicates that that is the positive side. And we'll often see the Greek letter epsilon next to it, or sometimes you'll see a certain voltage, because an EMF is the voltage source. And EMF actually stands for electromotive force. The terminology electromotive force comes from back in the days when they were first discovering how to do interesting things with electricity. And when, in fact, it was before they realized that it was the electrons that are free to flow, and they thought that there were positive charge carriers, and they thought there was something causing these positive charge carriers to flow through the wires. And that something was the electromotive force. In our usage, though, it's synonymous with a voltage source. You would probably be better to think of it as a voltage source. We'll also see a lot of resistors, especially in this section. In the next section, we'll actually start looking at capacitors as well, as you might have guessed. The symbol for a resistor actually varies. In many places, you'll see a jagged line. Maybe it looks like some mountains. And usually it's labeled with an R. Sometimes you might actually see a different symbol that's actually just a rectangle. Or I was going to say a rectangular box. That actually looks more like what a real resistor looks like. However, on the circuit schematic, we often just draw it. I will tend to draw it with the jagged lines, just because that's what I'm more used to. Often circuits will have a switch or 2 or 3 switches, and the basic idea with a switch is that you can change the way the current flows from one section to another. And the way it's drawn here, the idea is that it's an open switch, so electricity would not flow or current would not flow through the switch. And you could draw it as a closed switch. And I'll just draw it quickly as a closed switch and erase it because I don't want it to clutter the diagram. But a closed switch S would look like that. The next thing to look at is a capacitor. And I won't actually talk much about capacitors right here because it's sort of the focus for the whole next chapter. But a capacitor, in this case, shows 2 parallel plates or 2 parallel lines. It's similar to the EMF drawing, except the EMF drawing has one long line and one short line, whereas the capacitor symbol or drawing shows 2 parallel lines that are the same length. At the very end of the course, we'll see something called an inductor. And your prof may or may not get into inductors, depending on the particular curriculum that you're working with. And an inductor shows a coil of wire. That's what that is supposed to be. It's not a bunch of weird-looking hills, but it's supposed to be the wire, as if you were to wrap it around a tube, like a dowel of wood or your finger or something like that, and then take it out, and you'd have this coil of wire. And I'll leave explanation for that for much later. The last 2 things I actually talked about a bit in the intro. We have the voltmeter, and we'll be using that quite a bit. Actually, you're probably going to be using that quite a bit during your labs. I won't be using that so much in this course, although I do want to show you examples of how to use the voltmeter and how to set it up in your labs to help make your labs go a bit smoother. And the other thing that's related to the voltmeter is the ammeter. The voltmeter measures voltage between 2 different points, and the ammeter measures current flowing through the ammeter. Based on those core elements, circuit elements, we can actually connect them to form and create circuits. And I'll show a simple example. Probably the simplest example of a circuit you can get is to have some kind of a voltage source, so I'll list that as an EMF, connected to a resistor. This would be a really basic flashlight where the light bulb provides a certain amount of resistance, and the battery in the flashlight is acting like a voltage source. And as a result of that, you get current flowing, and then as the current flows through the resistor, it heats up an element. Or if it's a light-emitting diode, then it gets a different schematic, but this would be sort of an old-school flashlight, and it's much more common as a very basic circuit element. You can also have very complicated circuits like this one. When you see a diagram like this, if you have multiple resistors or multiple EMFs or multiple capacitors, whatever, you'll often have to label them with different labels. In this case, I have R1, R2, R3, and R4, and that's just because they could be different. In this case, there's also a switch, and this circuit could be doing a few different things depending on how you set it up. One of the key ideas, and this is the last key idea for the introduction here to circuits and circuit elements, is that the current in a circuit is often given the symbol I, and by definition it's the rate of flow of charge for time, so dq by dt. And the charge that's transferred is literally electrons flowing around the circuit, although we will typically draw current flowing in the direction of positive charge carriers. So it's opposite to the direction that the electrons flow. And the units for current are amps, which is why we have an ammeter. So we're already used to voltage from the chapter on potential, and the units for current are amps, which is why the ammeter measures current. And 1 amp is equal to 1 coulomb per second.